So we are looking now at IXL activity K6, where we identify proportional relationships from graphs and equations. We've been doing this for a little while now, and the first one would just give you two different graphs, and we have to determine if they are proportional or which ones are proportional. So again, there's two parts to determine if a graph is proportional. One, it has to be a straight line, and two, it must touch 0, 0, which we also call the origin. So let's look at these. This first graph is certainly a straight line. I see that it's a straight line, and it does appear to touch the origin, or 0, 0. So certainly, yes, that one is a proportional relationship between x and y. Let's look at the second one. And it's pretty simple. We go through the same process. Number one, is it a straight line? Yes, it is. It's a straight line. It goes from here straight down. Number two, does it touch 0, 0, which we also call the origin? Yes, it does. So both of these, if you're doing IXL, you would click both of those, and they are in fact both graphs that show a proportional relationship between x and y. Let's look at another one. This is a little different. This is in fact an equation. Remember on the previous IXL, where we did IXL K5, we came up with the equations for the proportional relationships. Now when we did it, remember the process was we started with y equals kx, and then we found the constant of proportionality. And remember, k is the same thing as the constant of proportionality. And once we found the constant of proportionality, we just rewrote the y and the x, and we replaced the k with the constant of proportionality. So both of these are in fact proportional relationships. So we know that they're proportional because the only thing that's there is y equals 7x. There is nothing else that is associated with it. And if you think back to the picture before where we said that the proportional relationship in a graph must touch 0, 0. It's a straight line that touches 0, 0. So let's take a look for a second. Will this be true? 0, 0 would mean that both the y and the x were 0. So if that's the case, then if we took this equation, which is the y equals 7x, if we replaced x with 0, that would be y equals 7 times 0. So y equals 7 times 0 would mean that 0 equals 0. So there is a relationship between the graphs and the actual equations. For your purposes, if you see a y equals 7x, 10x, 1/2 x, and there's no other information, then that's going to be a proportional equation. Let's look at one more, and it's very similar, and I think this might be your best example. You'll notice these two are different, okay? Now, everything we've done so far is we're talking about identifying a proportional relationship as a graph is going to be a straight line and touch 0, 0, which is also called the origin. We've also shown on the previous page the proportional relationship expressed in an equation that looks similar to this. Look at this one for a moment. This is different. Now, you see this little bit here, that little extra piece of information where it says y equals 8x minus 2. What that is really telling us is if that were a straight line, if we said that the x value was 0, and we just replaced it like we did a moment ago, that would be y equals 8 times 0 minus 2. That would be y equals 8 times 0. Well, that's 0. which means the equation would be y equals -2. It cannot be a proportional relationship because the straight line would not go through 0, 0. This is the origin here, and this is showing that the line would intercept the y-axis. This is in fact the y-intercept, that it would cross the y-axis at -2. So if you're looking at these equations and you see that extra piece of information, that is telling you where it crosses on the y-axis. If it crosses anywhere but 0, 0, then it's not going to be proportional. So the only one of these that is proportional is the y equals 6x. So that should help you with the activity. We will definitely do more regarding these equations and graphs to identify proportional relationships later.